Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem, fluid mechanics problem number 14. Okay, problem number 14. As usual, first we come towards the statement. Calculate the mass of a solid gold rectangular bar that has dimensions of 4.50 centimeter into 11.0 centimeter into 26.0 centimeter. Okay, quite simple, quite easy. We will have to find out the volume of this rectangular bar by considering one thing, that is say 4.5 centimeter as length, 11.0 centimeter as width and 26.0 centimeter as height. Okay, length into width into height. Okay, moreover we will convert centimeter into meter. Okay, this is our discretion. Even if we do not convert it at initial stage, we may convert it in the last stage of this problem. Okay, so now we come towards its solution. Okay, dear students, we start solution of this problem quite in a similar manner as our most of the other problems of this course, that is fluid mechanics. Okay, so first we are going to define density rho. Okay, first in wording, then in mathematical expression. Okay, density is mass per unit volume. If a mass m of homogeneous material has volume V, then its density rho is given by rho equal to m over V. Okay, equation number 1. We know from table of densities that density of gold is 19,300 kilogram per meter cube. Okay, we show that table. This is the table of densities. Okay, so here at second column and row number 7, density of gold is given as 19.3 into 10 raised to the power 3 kilogram per meter cube. Okay, in other words, we can write it as 19,300 kilogram per meter cube. Okay, so we have done so. We know from table of densities that density of gold is 19,300 kilogram per meter cube. Rearranging equation number 1 as m equal to rho into volume. Okay, when we will keep mass m on one side, then volume V will be multiplied with rho. Okay, so m equal to rho V, and using volume equal to length into width into height. Okay, so we have assumed one thing as length, other thing as width, and the remaining third thing as height. Okay, length into width into height. Volume equal to length into width into height, we get m equal to rho V. In place of rho 19,300 kilogram per meter cube into 0.045 meter. What we have done? We have simply converted centimeter into meter. Okay, 4.50 centimeter has been converted into 0.045 meter. Similarly, 11.0 centimeter has been converted into 0.11 meter. Similarly, 26.0 centimeter has been converted into 0.26 meter. And hence, after simplification, we get mass equal to 24.8391 kilogram. Okay, we can simply round it as nearly equal to 25 kilogram. Okay, irrespective of whether we round it as 25 kilogram or we keep it in this form as mass equal to 24.8391 kilogram, there is no difference. Okay, both results are quite acceptable. Okay, now we come towards the reference book from where this problem has been chosen. Book name is Physics for Scientists and Engineers with Modern Physics. Its authors are Raymond A. Survey and John W. Jude Jr. Its publisher is Cengage, and its ninth edition, having been published in 2014, has been adopted. And here chapter number 14 under title Fluid Mechanics is our concerned chapter, and this problem is enumerated at serial number 5 of the exercise at the end of this chapter. Okay, that is to say exercise number 14.5, and this is the end of our problem. Okay.